And we're live.
So I called this acceleration introduction. If you turn your brain on, then everything I do for the next few days should fall into this, just more formally. Acceleration is speeding up or slowing down. And so I wrote here, suppose you are at rest, and you begin to accelerate to the east at a rate of 5 meters per second every second. But we don't write it that way. Rewrite it like this. 5 meters per second per second. Let me make that a little neater since my whole desk moved here. 5 meters per second per second. Actually, we don't write it that way. Sarah, what we really say is 5 meters per second squared, because there's two S's on the bottom, and when you have two S's side by side, that's the same as squared. Acceleration is measured in meters per second squared, or kilometers per hour squared. It's measured in distance divided by time squared. What does that mean? That means every second, in this particular example, you're accelerating by 5 meters per second squared. So I wrote here, complete the following chart. This is a time velocity chart, Hayden, my friend. And at time 0, how fast are you traveling? There's a key word that we're going to underline here. That word right there. How fast are we traveling to start out with?
0.
Now you start to speed up. And you speed up at a rate of 5 meters per second every second. At 5 meters per second per second. At 5 meters per second squared, which is the easiest one to say. So after 1 second, how fast am I traveling?
5 meters per second.
Direction. Which direction is my acceleration? East. I wrote that in the original paragraph. It does say. I keep accelerating. After 2 seconds, how fast am I traveling?
10.
Direction. Spot the pattern. After 3 seconds, how fast am I accelerating? Sorry, how fast am I traveling? 15. Justine, keep going.
20.
And then?
25.
Okay. Can you spot a pattern, Justine, where if I hadn't given you these first 4, you could get that number knowing how long and the acceleration? Okay. Part of our acceleration equation that I'm not going to give you today, but that will formalize, there's going to be a acceleration times time. Example 2. Okay, now we're not starting at rest. Suppose you're traveling at 4 meters per second east, and you begin to accelerate to the east at a rate of 5 meters per second every second, written as 5 meters per second per... Oh, heck. 5 meters per second squared is the much shorter way to write it, Amy. Are you starting at rest this time, Josh? No? Okay, at time 0, Josh, then what's your speed? Sorry, what's your velocity, magnitude, and direction? Hayden, my friend, what's our rate of acceleration? Can you read it to me right there, kiddo? Okay, so if I start out at 4 and I'm increasing my speed, if I start out at 4 to the east and I'm increasing my speed at 5 meters per second to the east, after 1 second, do the math, how fast?
9 meters per second.
9, or is that a German saying no? Yeah, you're waiting for that joke, I know. 9, okay. Direction, Dane?
East.
Okay. Hey, Mr. Dueck, what happens if your acceleration is in a different direction than your velocity? We call that slowing down. We'll look at that in a bit. After 2 seconds, Brendan, how fast am I traveling? 14. Spot the pattern, yes? How about after 3 seconds? How fast? 19? After 4 seconds, how fast? Sorry? 24? And after 5 seconds? Oh, forgot the meters per second. All right. What if I didn't give you 0, 1, 2, 3, and 4 second speeds? Is there any way that you could figure out that 29 based on 5 seconds, the acceleration, and the other information I gave you in this question? Yeah.
Multiplied by the 5 meters that you measured, the 4 seconds that you started at.
I like his numbers. I hate his units. And I'm going to quote you. This is good. You said multiply by the meters and then add the 4 seconds that you started at. I'm going to say that a little differently. What's your, can I use a physics word, initial velocity here? See it? At time 0, 4 meters per second. What's your acceleration? 5 meters per second squared. How much time has elapsed grand total? Our eventual equation, we'll write this down, but I'll do it more formally. It's going to be this. The final velocity is equal to your initial velocity plus the acceleration times time. Justine, that's actually what you did in the previous question, but our initial velocity in the previous question was 0. That's why that vanished, and it was just straight acceleration times time. All right. Example 3. Suppose you start out traveling at 10 meters per second west, and you begin to accelerate to the east at a rate of 5 meters per second, written as 5 meters per second squared. What's your velocity at time 0? How would I write 10 west if I didn't want to write the word west? Okay, so we're going to now drop the east and west, and we're going to think about it in terms of negative and positive, because that's going to make the math a little easier. So how would I describe that? All right. So I'm traveling west, but which way am I accelerating? East. So after 1 second, who can see what my velocity is going to be? Ty, what? -5. You're going -10. Which way is west for you guys? That way. -10 that way, but you're accelerating this way. What's really happening is you're slowing down a little bit. Still heading that way, but not as fast. -5. Meters per second. How fast will I be traveling after 2 seconds? Huh? 0. Is that right? In fact, you know that, so I was traveling west, but I'm slowing down at 2 seconds. For a split second, what have I done? Come to a complete stop. But I'm going to then start accelerating to the east and speeding up that way. In fact, now, after 3 seconds, how fast will I be going?
5,
Then?
10,
Then? And let's put a positive just to emphasize that it's to the east, and a positive just to emphasize that it's to the east, and a positive just to emphasize that it's to the east. By the way, see the little equation that I wrote up here? Let's see if that still works. If I can get that value at 5 meters per second by going initial velocity. What was my initial velocity? -10 plus acceleration, +5 times how many seconds? 5 seconds. And hey, that gives me the 15 as well. I can get there without doing all the intervening steps if I need to. That's next lesson. For now, we will do the intervening steps. All right, smarty peoples. Suppose you're traveling at 7 meters per second west, and you begin to accelerate to the east at a rate of 5 meters per second, which oh, can you tell I was cutting and pasting this as I was typing in a hurry, Dylan? 5 meters per second squared. All right, complete the following chart. How fast am I traveling at time 0? Or if I want to use my physics term, what's my initial velocity? I disagree with 7. I agree with -7 or 7 west. But since I'm tired of writing west and east, I'll just call it negative. Jacob, that was a convenient stretch, but it also looked like maybe you were going to raise your hand. After 1 second, can you see how fast I'm going to be traveling? If I'm... Nice, -2. After 2 seconds, how fast will I be traveling? Can you see it? I'm going to give you a hint. Positive. Huh? +3. If I start out -2 and I accelerate at 5 meters per second to the right or to east for 1 second, I'll pick up an extra +5 meters per second, which gets me to 3. And you know what? I'll even put a positive sign in front of there to emphasize I've changed direction. I'm now going... In fact, can you tell me when I came to a stop for a split second? Between which 2 seconds? Sometime between second 1 and second 2, I came to a stop for a split second, Dylan, and changed direction. How fast will I be traveling 3 seconds in? +8. $18, did you say? Yeah, I just couldn't read your lips, sorry. You can speak loud, it might even wake Hayden up.
Ah, I see.
Okay. Let's start out traveling east at 7 meters per second. And let's accelerate west at a rate of 2 meters per second every second, written as 2 meters per second squared. By the way, when your acceleration is in the opposite direction of your initial velocity, we say you're decelerating. Slowing down, if I don't use the physics term. Complete the following chart. Try this one on your own. I'll do it up here. See if you can get the same thing. Oh. Come back here. This whole thing is sliding back on me. I think initially I'm +7, and I'm losing 2 meters per second because I'm accelerating to the west. So I start out 7 to the east, but I'm slowing down. 5 to the east, 3 to the east, 1 to the east. Sometime between second 3 and 4, I come to a stop. In fact, I'll bet you exactly at 3.5 seconds is when I come to a stop, since it's a nice even split. Then I'm starting to head backwards. -1, -3. I'm accelerating backwards, or you can say I'm decelerating forward still, which is the same as accelerating backwards. To me, Emily, the most interesting aspect of acceleration is what we call free fall. This is free fall, dropping something due to gravity, or throwing something up due to gravity. When something is traveling in the air, it's accelerating. You know how I know it's accelerating, Sarah? Because its speed is changing. And that is the definition of acceleration. We'll talk about that next class. But acceleration is the rate of change of speed. And I happen to know that when you're accelerating due to gravity, acceleration due to gravity is downwards, negative or positive? Negative. And it has a value. Its value is -10 meters per second squared. Actually, in Physics 11, we'll be fussier. It's -9.8 meters per second squared. But -10 is a close enough number for our purposes today. So, example 6. Turn the page. Suppose I throw a baseball, golf ball, straight up. I don't have room here in the ceiling. Suppose I really heave it straight up so that it leaves my hand at 30 meters per second. Going up, I think Amy will call up positive and down negative. So it leaves my hand at 30 meters per second. Good, then stop making noise. Brendan, what's my initial velocity? Now we're thinking up and down, up positive, down negative. What's my initial velocity at time 0? Positive 30. Let's write a little plus and a 30. And on the previous page, let's write it right here, the acceleration due to gravity, which traditionally we represent with a lowercase letter g for gravity, is negative 10 meters per second squared. It's actually negative 9.8, and eventually we'll use that and use our calculators, but negative 10 lets us do the math in our head, and we're close. So how fast will I be traveling after 1 second? Positive 20. Still on my way up, but I've slowed down. How fast will I be traveling after 2 seconds?
Positive 10. Stop.
Huh?
I think you're at 0.
So what does that mean? The ball has reached the very what?
Bottom. I know. Stop.
Okay? I can actually calculate how long it takes to get to the top of its arc and starts coming back down. When? When v final equals 0, and if we had the equation, then I could actually solve for t, even if it didn't work out evenly. This one does. Now what?
Negative.
Coming down? Now what? Will it hit negative 40? Not if it comes back to the same height. If you throw something and it comes back down at the same height, it hits you at the same speed as it left you. In fact, we have a saying, what goes up must
Come down.
That's actually, there's some good physics there. Now, if you're throwing it while you're standing on a cliff or on a balcony, that's a whole different issue because now it can fall past you and keep going down and keep accelerating, 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 accelerating. That's different. So, see if you notice a pattern in the chart there. Because example 7, I said, suppose I throw a baseball straight up at 50 meters per second instead of 30 meters per second. When will it reach its maximum height? When? I want a time. What? Josh? I think you're, someone back there was right. Was it?
It was 5 seconds. Yeah.
Why 5 seconds? First second, at time 0, you're at 50, 40, 30, 20, keep going.
10, 0.
Ooh, when will it reach its maximum height? Because I started counting at 0, 5 seconds. I really should have said this. At time 0, you're at 50. At time 1, you're at 40, 30, 20, 10, 0. When will it reach its maximum height? That's a 5 and then an S for seconds. That's not SS. When will it hit the ground?
Oh, okay. Yeah.
In actuality, the acceleration due to gravity is negative 9.8 meters per second squared. And we measure it in Physics 11, and it's easy to calculate. Why negative? Yeah, gravity acts downwards. So, example 8. Mr. Dueck jumps from an airplane. Anybody else jump out of a plane? Just me? Okay. Now, when I jumped out of my airplane, because I start out sitting on the edge of the plane, what's my initial vertical speed? Think about it. 0. Okay? So at time 0, I'm traveling 0 meters per second. And then I jump. How fast was I traveling after 1 second? We're not going to use 9.8. Let's use the 10. How fast was I traveling after 1 second? How fast was I traveling after 2 seconds? Negative 20. By the way, if you use the 9.8, it's negative 9.8 and then negative 19.6. But 10 is close enough for now. How about after 3 seconds? Spot a pattern? Okay, let's skip some. Can you fill in, what would I put for 8 seconds? Negative 80? After 13 seconds, how fast was I traveling? Basically a football field and a half every second. You're hauling. This is free fall. Why is this technically not accurate besides the 9.810 thing? Air resistance. In real life, air resistance plays a part. The numbers that I'm giving you, that 9.8, that's really free fall in a vacuum, or free fall in outer space, or free fall if we sucked all the air. Or if you're really, really, really aerodynamic. Now, having said that, a golf ball, for example, is aerodynamic enough that if I drop it, even with air resistance, it's about negative 7.99. It's close enough that generally in physics we pretend everything is a big lead sphere, aerodynamic and really heavy, so air resistance is going to play much of a role. We ignore air resistance because it's tough to calculate. How many of you have ever held your hand out of the car window when you're driving? Okay. You feel the air resistance, yes? Air resistance, is it bigger or smaller when you speed up? Bigger. See, air resistance, Hayden, is a very complicated force to calculate. It changes as speed changes. It changes, if you do this versus that, which way is there more air resistance when you stick your hand out of the car?
When you have your palm.
Okay. It changes based on your, ready for the fancy word, cross-sectional surface area, your cross-sectional area. That's why when you skydive, you do the classic skydive position. You're trying to make your surface area as big as possible, because if something does go horribly wrong, you would prefer you to have maximum air resistance still. Does anybody know what you call it? Because air resistance is real. In free fall, you speed up, but air resistance gets bigger, bigger, bigger. Eventually, you hit an equilibrium point where you're falling as fast as you possibly can. Does anybody know what you call that? Begins with the letter T, and the second word is velocity.
Terminal velocity.
Terminal velocity. Okay? So, first of all, Mr. Dueck was in free fall for approximately 30 seconds. How fast was his maximum velocity? Well, in theory, should be negative 10, negative 300 meters per second. That's, Hayden, if there was no air resistance. In reality, terminal velocity, it's about 190, 200 meters per second. Start slowing down. So, in reality, these numbers aren't completely accurate. Air resistance. But Ty, if the object that's accelerating is reasonably aerodynamic, cannon, baseball, bomb, all those things, our answers will be close. Quite close. Arrow is a nice one. Our answers will be close. Put your pencils down.